Okay, so then this other concept that we went over was basically about the touch receptors. Again, you can have this link in the email, or you could just write this on a piece of paper, and then when you get the handout, you could fill it in. But we have different kinds of touch receptors in our skin. Not only are these located in our skin, they're also located in our eyes, nose, and tongue. So within the skin, eyes, nose, and tongue, there are cold receptors, thermoreceptors, that actually get activated at a certain degree. So when they're most activated at 77 degrees, but they stop responding when the skin gets as cold as 41 degrees, or the tongue. At that point, when it's that cold, the pain receptors actually start responding, which the pain receptors are technically called nociceptors, which means you're hurt, noci. And then we also have these heat-activated neurons, another type of thermoreceptor, but different than the cold ones. They get activated when the skin is above 86 degrees, but most activated at 113, and then they stop where the pain receptors again take over. Our skin, our nose, our eyes, our tongue all have pain receptors, again, nociceptors, and they also have touch receptors to know when something, they can feel when something's on it, and also pressure receptors to know how it's touching it. So we were going to just take in these notes about the transduction of touch. How is touch, this outside stimulus, getting to my brain? Sensory, or remember what they're called, afferent neurons, arrive to the CNS or brain and spinal cord, where they go to what thing first? Do you remember where they have to go first? That's right, the thalamus. And then to what lobe? Do you remember where touch, temperature, pain is? What lobe is that? Think piranha. That's right, parietal lobe, where there is what kind of cortex? If you said somatosensory, you got it. These receptors are all over the body. So we're going to answer these questions in a form, and I'm going to just retype them. The one thing that you're going to get to, I just want to draw a picture of, is something called the gate control theory of pain. And so I'm going to go to Draw Island to draw this. But what this theory says is that we actually have a system within our body to stop sending pain signals to the brain. And the theory says that if you do other things while you're in pain, you can actually stop the body from feeling pain. So here's a person, here's their spinal cord, and what this theory says is that if you do certain things, which I'm going to say what they are right now, let's say this is the spinal cord sending pain signals up to the brain. If you do certain things, like for example, deep breathing or massage, you can actually stop those signals of pain. Again, by things like deep breathing, massage, even acupuncture has been known to help people reduce signs of pain. So this is why women, they go to Lamaze classes to learn how to breathe deeply while giving birth, so that they could try to reduce the feeling of pain. You probably have stubbed your toe or done something where you try to rub it or massage it. Again, the theory is that somehow we send a signal. It's not a gate, even though it's called the gate control theory, but they think it works like a gate, that it literally just stops the pain signals from being sent to the brain.